Vegas is fun, a lot of fun games. Anyone win anything? Speakers get 10%. Did anyone tell you that? No. No one won anything anyway. Yeah, I already experienced that over the past couple of days. Thank you. I've already contributed to the hotels. Yes. I love games. Gambling a little bit, but I'm actually on Windows Phone. Big gamer, actually. Play a lot of the Xbox Live games. Finished Assassin's Creed, finished Star Wars, working on, that's true, really. The guys down here that I work with are laughing at me. It's testing the platform. That's what I tell Joe. That's what it is. But truly, I do that. But the one thing I really hate is I go out of the game, I come back in, you're waiting with the little resume and the fun little dots. Hate that. So Joe said, hey, Darren, you're going to own multitasking. What's your priority list? I said, we are so fixing this. That is my number one. We're going to fix the fast app resume, and then let's do some other stuff as well. But that was my big one. So my name is Darren Miller. I'm the lead program manager of App Model and Multitasking for Windows Phone. I'm doing what's called part one. We have such a large movie here, we couldn't do it all in one session. So we actually have a part one, and we have a sequel tomorrow. The amazing Mr. Peter Torr will be getting his hands down and dirty in true Vegas style in terms of the code, debugger, developer experience, and so forth. I drew the short stick and got all the PowerPoint slides from Peter. So count his slides. He should have less than what you count on one hand. And I'm pretty sure he does. So what I'm going to go through a lot is around the principles, the tenets, the design, the scenarios, the features, and so forth. So, my little clicker here. So start off with what I was just chatting about. You guys have seen this in MWC, saw this in the keynote. First part of multitasking is really allowing the user to multitask between applications, being able to quickly switch, as well as quickly resume. Very, very cool. I love this feature. It really is my favorite feature. What else do we have? Well, we also have scenarios where we want to start an experience in the foreground and continue it in the background. Here I have a really, really nice audio application. I go ahead and start it in the foreground. I back out of the application. And the audio continues playing in the background. I'll get into some more details there. Third but not least is starting something in the background. So here I have a little application where it auto-checks me in. I go ahead and say automatically check me into the Mandalay Bay. I back out of my app. And then sometime later, while I'm walking around, while I get within the vicinity of the hotel, it automatically checks me in. So this is the case where I've set it up in the foreground. Sometime later, the experience actually has started in the background. So we'll get into how that's possible. So kind of three main facets of multitasking. Just kind of level set everyone. Okay? All right. Now, before we really kind of get into anything, we'll get into what we're doing for Mango. I wanted to start with what I'm calling Windows Phone Harmony. Now, what is that? I would say it's the harmony of user experience and health. In Windows Phone, currently today, we have great user experience, got a lot of great feedback from reviewers, from users, from developers, and the experience of the phone, as well as great health of the phone. So specifically, what am I talking about is that fluid, delightful, responsive UX, UI that we have, that Metro-style UI that we have. It's well integrated. The applications are integrated, either the ones you bought or that you got with the phone that you bought from Marketplace. Feels like all the same experience instead of experiences, which is great. And then also part of this is never regretting installing an app. Isfan mentioned this as well. And this is really kind of the mantra of the application platform team within Windows Phone, is where a user goes to install an app, and they should feel that, no user data was harmed in installing this application. Right? So we do take that seriously. It's a very big deal in terms of how we are thinking about the application. Now, the other part of the yin and yang here is health. Try to be extremely battery friendly. The number of ways we do this, but battery is obviously probably the scarcest resource on the device, so being very, very friendly in terms of what we do there and how we utilize the battery. Being very network conscious, this helps cell bills. This is a great thing for our MO partners in terms of just being very, very conscious in terms of how we utilize that cell network. And last but not least, providing a set of what I'm calling hardened services. And really what this is the OS itself, providing a well-tested set of services in the operating system that applications can use. We have millions of test cases against tens of thousands of devices. I'm actually not exaggerating. We do have that back in Redmond. Huge labs of these devices and tests that are running against the OS. We did this for Windows Phone 7. We carry that forward into Mango as well. So one of the things that we need to kind of stem from this is, why didn't we have multitasking before? And kind of in a nutshell was, we owned a lot of the pieces before. I mean, Windows Phone 7, the hardened services, we can harden them, we can stress test them, we can make sure they're performant. When it comes to code that we don't own, it becomes a lot more challenging, right? So you need to kind of really think through, how do we maintain that great harmony with code that we don't own? Clearly the OS can do multitasking. Under the covers, email, you get email syncing, right? You can get phone calls. So under the covers, I mean, if we want to do this, we can say, hey, fire up a couple processes, done, my presentation's over. You may have extremely crappy health, maybe not, maybe so, depends on the app. Will the end user regret installing an application? Probably, right? So let's not go there. So let's take a look at that, kind of with that teed up with multitasking and phone health, and kind of how do we approach this, and what are kind of the design principles? First is, we have this great OS. Let's see if we can extend it with some additional services that you all can use in your applications. That has huge advantages for you in terms of offloading and doing the heavy lifting to the operating system. It makes it nice for us in terms of Windows Phone, where we can take that service as part of the OS and harden that, make it performant, throw it in our huge labs, and kind of a nice good for both sides, right? Win-win situation. Next thing to look at is, if we do need to run application code, let's do it on demand. And do it when necessary, and only when necessary. Along with this, going back to our harmony, is to balance the foreground and background. A lot of you have created, how many people created Windows Phone applications? Everyone raise their hand. Thank you, makes me feel so much better if everyone raises their hand. So what you don't want to have happen is, we introduce multitasking, your neighbor next to you goes, oh, this is so cool, I'm going to do a bunch of stuff in the background, and the user using your application, all of a sudden it sucks. And who gets blamed? Is the guy that used all the resources in the background? No, it's your foreground app that looks bad. So we need to look at how we balance those. And this one actually talked a lot about this. If you want to understand a lot of the details and the underpinnings in the architecture, definitely take a look at his talk. It's an extremely important concept in terms of being able to balance what's happening directly to the user as well as what's happening kind of in that background. Another thing we can do, and this goes back to a lot of being smart around battery and being network conscious, is aligning it with current user activity on the phone, or aligning the background activity together. And a really good example of this is the radio. The radio is one of the most expensive resources on the phone. If we can align radio access together within reason, then it should save battery. So thinking along those lines with the other resources as well could be great for the user in maintaining that harmony. And then, unfortunately, in the real world, not all apps are meant to be good apps. There is malware in the world. I'm sure folks have experienced that. Probably everyone, of course. It's an unfortunate reality of what we have. And so we want to make sure that, if an application decides to be naughty, we slap it around a bit and kill it. Or basically manage it. And basically look at its resource utilization and say, okay, hey, something seems to be off here. This also may be if there's some bugs and things like that. But malware is kind of the extreme example, kind of looking at and making sure an application doesn't get out of hand. And this really goes back to that tenet of the application platform, is a user never regrets installing an app. Or maybe regret it for a very small period of time until we get rid of it. Okay, so what I'm going to talk about today really falls into three main buckets. A set of services, kind of teed those up already a little bit here. We'll go into the details. A set of new OS services you can utilize. Agents, we've talked about this in the keynote and a couple other presentations in terms of you can think of it as a transient service of your app that can run as invoked by the system to do some cool stuff. And really tying the whole thing together is resource management. We've got a lot of new stuff floating around in the system. We want to maintain that harmony. We have an enhanced resource management system that ties it all together and makes for a great user experience and great health. So just real quickly, we talked about this a little bit in terms of fast app switching. We have this fabulous resuming dialog, ... You guys have seen this before. Yes, I do. I truly do hate this. And sometimes, after that, you get some sort of a cheesy dialog of some sort as the application's loading. So how do we get from whining about cheesy dialogues, I got to get at least one smile off of that, to this? So really the question, I think, would be from you to me, like, hey, what can Windows Phone do for me? So first off, we provide user control. Windows Phone 7, we provided a back button to back through the back stack. In Mango, we provide an ISO affordance. You've seen this in a couple of demos already. You saw this in MWC as well. It allows you to really kind of take that stack and turn it into a linked list, if you will, and allow you to kind of choose an item out of that list and move it to the head of the stack, or head of the list. App dormancy. Effectively what this is instead of pitching the app out of memory, why don't we just keep it in memory if we can? That sounds like a novel concept. Well, let's do that. We're doing that in Mango. If you didn't see Adina's talk earlier today, I would definitely recommend you to look at the rerun. We tape everything. Take a look at that. She dove into this in great detail. And then last but not least, with this type of change, one question would be, hey, what about my current apps, or apps that are on my phone now? Or if I have an app, what about my users that have installed that? Does everything continue to work? And it will. Backward compatibility is a huge deal for us in terms of as we move between versions. And so we want to make sure that the applications are compatible. Now, Windows Phone 7 applications running on Mango will continue to be tombstoned. Okay? And part of that is like maintaining that is what you tested against, right? When you did your application, want to make sure that it follows all the same paths as it did before. What we don't want to introduce is some sort of change where it breaks some sort of functionality on your application. So what does the developer need to do? What do you all need to do? Well, possibly nothing. For a lot of applications, and you've seen these in demos, or unaltered, a lot of them are unaltered applications that simply run extremely well in this kind of dormant state and this fast application switching and resuming. But really, the first thing would be compile and test for Mango. So maybe not a lot of code changes, but some additional testing. We have up the platform. As you compile to Mango, is an indication to us. We rev the version number of the platform. We say, hey, you've tested in the new platform. We'll go ahead. That's an indication to the platform that you support fast app switching. So kind of think of it that way. Load state only when necessary. I'll get into what that means. And reattach resources. Those last two are optional depending on the app. Some apps will be required to do this and some not. So let's get into this a little bit. It's the application lifecycle. This is pretty much the same diagram that Adina showed. This is pretty much the same one that we showed last year. Start with a running application. We deactivate it. And here what you want to do is go ahead and, this is your last chance to save state. Now this is a simplified diagram for those that have developed apps. You want to save state off the pages on navigated from. You want to do that on every page, so I'm kind of simplifying that. Okay. But the last chance of saving state is in deactivated. From deactivated, we go to what we're calling dormant. And what does dormant mean? Really, keep it in memory, or pause all the managed threads, and detach a lot of the underpinning of the platform. Things like camera is a good example. Like, well, if it's going dormant, I don't want that application to hold on to the camera. I want probably my next app to be able to utilize the camera. The camera is an exclusive resource. So we've done a huge amount of work in the platform and framework to detach the resources from underneath for things like exclusive resources. The other thing we've done is detach things like network, who may get back some sort of event while the application's in dormancy. And we do that so that We don't have this kind of background ambient CPU that's not being managed. We can kind of manage that well and kind of manage this dormant state of the application. From dormancy, the application can be reactivated. Here you want to go ahead and, oops, sorry, let's go back. It's reactivated just like it was before, and you can attach resources and so forth, and you're back up running. Now, it's possible that an application in the backstack that is dormant may need to get tombstone, may need to get pitched out of memory. So need to handle that state as well. So from the dormant state, can be tombstoned. And in this case, what you want to do is reload your state only if you were tombstoned. Now, you don't have to, but your app's going to be a lot better if you don't like reload state when you don't have to. So we do give you a nice little API in Mango to be able to detect whether you're tombstoned or not. So if you were, then reload state. If not, don't. So fairly simple. Okay, so the next thing I want to do is get into these new services. First one is a notification service. Notification service, first off, allows you to create alarms for your application. You can think of it as a baking application or some sort of actually Qantas, the application that Joe went through in the keynote, could utilize alarms as well. So any number of scenarios where you might want to utilize alarms in your app. And you can think of this as that we just put an API on top of the alarms app that already exists on the phone. And in fact, from a user's perspective, it looks exactly the same. The UI is the same. It acts the same way. It adheres to the user settings and is modal to the system. So actually, let me take questions at the end if you don't mind. That'd be great. So next, and then I just kind of put some sample code here. Next would be reminders. Reminders are a little more rich. Reminders are the similar reminders which you currently have if you create a calendaring item and create a reminder off of that. Here you can create your own calendar and create a set of reminders. The reminders stack and behave just like kind of the first-party reminders in the system. They'll stack with all the other reminders from calendar or other applications. And they're a little more rich in terms of snooze, dismiss. You have a little more metadata associated with them. Now, how many people in the audience know that if you press the text of a reminder, it'll actually take you to the calendar? A couple people know. Everyone else? Actually, that's true. You can try it out. If it falls over the lock screen, it won't work. So that's a little tricky part. But don't feel so bad. I didn't actually realize this until way late in 7 that you could actually do this. And that functionality we carry forward as well. So I just kind of highlight it here. Is in your own reminder for your application, you can have that functionality. You specify the navigation URI. So when the user presses the text, it'll actually navigate and launch your application with a set of parameters. I don't show them here, but you'll get a set of parameters. So you can bring up your application in the context of the reminder. So very, very cool. Pretty much identical to what the calendar does now. So now everyone knows you can press text. Everyone's like pressing text on their phone. So a couple other cool things with regard to alarms and reminders. Because it is an OS service, we're allowed to do some. It enables us to do a couple cool things. First off, we can persist across reboots, just like calendaring items and alarms do now, right, which is very nice. Like I said, it aligns with the other notifications in the system and adheres to the user settings. So if the user has turned them off or done some modifications in the settings control panel, alarms and reminders from third-party apps adhere to those as well. Transfer service is another service that we've included in the OS for Mango. And effectively what this allows you to do is transfer things in the foreground and continue in the background, kind of going to that second facet of multitasking. So I got a nice little application here that downloads books. I'm going to go ahead and check on my Cheese and Wine book as well as Great Mysteries book. And what happens under the covers is my application, which is the green box, talks to the background transfer service as part of the OS. I kind of have a sample set of the API here. Actually very simple API. That's pretty much it to be able to kind of get things going, create a new background transfer request, add a couple events that we'll use a little bit later on, and add it into the service. And once it's added, it goes ahead and transfers it from, in this case, from the cloud. You can specify typically transferring it from the cloud down to the ISO store. And what I'm doing here is utilizing one of those events that I had hooked in to set the progress. And so I can just continue running this in the foreground, continuing getting progress. In my app, I'm adjusting the little green bar. And it makes actually a really, really nice, simple API to use. It's actually simpler than HTTP web request. Folks have probably used that already. That's a fabulous API, don't get me wrong, but it's a little complex. It's very, very powerful. If you just want to do uploads and downloads, the background transfer service API is pretty handy. Now, unlike what you have in 7, unlike HTTP web request, if I back out of my application's gone, that download or upload continues to be processed, which is very, very cool, even across reboots, even across some errors. Background transfer service will also handle a certain amount of retries. So a lot of heavy lifting on your behalf while your application isn't running, kind of doing a lot of stuff for you, which is great. Now, what happens if I go back in my application? How much can I control here? And you can control pretty much all the requests that your application has. You can delete them, you can restart them, you can stop them, and so forth. What I'm kind of demonstrating here is I went back in my application after some time. The first one, via my the bytes received off the request, I'm basically saying, hey, one of them was completed and one of them is still going on. And I'm not showing the entire API here. It just kind of gives you an idea of how to utilize the background transfer service. Peter will go into a little more detail tomorrow morning around this, but you can imagine that you do have control of being able to add and delete the various requests. So kind of a very, very nice facility, hardened service, part of the OS that does really the heavy lifting for your application. Now, the background transfer service actually is based on top of the marketplace service. And so we kind of continue with those same limits to make it easier for the developer, for you all, as well as the user to understand kind of what the limits are. So what we've done is limit it to less than 20 megs. We'll go over the cell network. The reason we did that is for the same reason we do it in Marketplace, is so that you don't have massive bill shock, so we're balancing that kind of health and experience. Now, what happens? People out here looking at me going, it's over 20 megs, what do I do? Well, just like with Marketplace, I can go ahead and queue up my file that's greater than 20 megs. It won't download until the user plugs into Wi-Fi, and as soon as they do that, and then it'll go ahead and continue to download. Okay? Now, I'm showing downloads here. You can also do uploads via post, which is pretty nice. And with post, here we're tuning exactly what the limits are, so that's why I put the little tilde. So we're kind of trying to figure out what the right limit here is. But the way to think about it would be we'd want to enable the scenario where someone needs to upload a picture. That was a fairly common scenario when we talk to customers, or what they wanted to do with being able to upload to the cloud. And so this number will get tuned to kind of what the rough size of a picture is for Mango. Now, why isn't this some really huge number? It's for the same reason the other isn't a huge number, is that we want to maintain good memory footprint on the system. We want to maintain that the service is very healthy, doing the right thing. The more memory it uses, the less dormant apps we have, which kind of sucks. So we kind of want to balance. All these things are kind of balancing each other. All right. So the next one is background audio. This one's pretty cool. There's a number of ways of doing background audio in Mango. The first and really the simplest is HTML5. We have IE9 supporting HTML5 in the browser now. Just create your site with an audio tag. Go ahead and fire up that, hit the page. In this case, I'm playing Demo 1 MP3. And although I go ahead and get out of my browser and back to my wallpaper of a nice self-portrait, I know the camera adds 10 pounds, so I know that. The audio continues to play. Now, the other really nifty thing for those that are really looking at my API here is an on-ended event. What about that? Well, the audio is continuing to play. If I have JavaScript that has implemented this, actually, it'll continue to get the next track. So when the track ended, it gets the next track automatically. So a really, really simple way of creating kind of a continuous background audio application, if you will. But it's really just a website and our browser hitting that website. We also allow you adhere to pause and play in the UVC as well, of course, volume control. And a lot of that's because we're using the Zune service. And what I mean by the Zune service, by the way, is a service, the process on the phone, not a cloud service. It's actually the phone. Okay? So a very, very simple way of doing background audio with HTML5. You get next track automatically, and a very simple set of markup to have background audio. Now, if you need a little more flexibility, we do have what I call a URL-based API. And this is where you're kind of building an application that is running on the phone, gives you a little more flexibility. So I have a very simple app here. We kind of showed this before. Here with the code. So I fire up a background audio player. I go ahead and play it. Here I can grab the information from either local playback and ISO store or from the cloud. Either one's fine. And again, utilizing the Zune service to do the heavy lifting. So it's playing kind of on behalf of the application. Now, if I go ahead and go back to my fabulous wallpaper here, the audio continues to play. You can tell that by the new hardware that we have in the chassis of that little circle with the speaker. By the way, I'm kidding about the chassis. I didn't mean that. So just imagine the audio continuing to play there, which is very, very cool. Now, I said this was a little richer than the HTML5 scenario. In this case, I can implement not just pause and play, but also next track and previous track. So the user goes in and says next track, and the next track magically happens. Now, I say magically happens is suddenly I have my green box there of my application running, but my self-portrait is still in the foreground. So what's going on here, right? My application isn't in the foreground. My application isn't running. Or is it? So really what's happening here is agents. And we'll go into kind of what that means. This is actually what's being invoked here is a background agent part of that application. So what this allows you to do, I can be using the phone doing something else, have my phone in my pocket, browsing the web, looking at my fabulous pictures and wallpaper, and my music continues to play as long as my application knows how to process next track. Or I can go in the UVC and press next track or previous track. So quite a bit of flexibility. Now the other thing we allow is sometimes providing just a URL or just a file isn't good enough. We're talking in the modern world, people like to protect their IP for whatever reason. So we have encrypted files, we have compressed audio files. In those cases, the application needs to do a little bit more. And we allow you to not just provide a URL, but instead a buffer. And so with this, you can get a buffer off, let's say off the cloud or off an ISO store, process it, and provide to the Zune service a buffer. When the buffer is just about to run out, the Zune service will say, hey, give me the next one. And this allows you to do a little more advanced scenarios of being able to decompress or decrypt that audio. So really what we have here is a very rich way or several ways of doing background audio. HTML5, file-based or URL-based, as well as streaming. So let's kind of get into what this magical green box business is. So first, I want to start with the architecture we have today. We have an application, My App, nice, ingenious, creative name, has UX, has logic, connects to the cloud, connects to ISO store, and crosses the boundary in terms of using system services. Fairly straightforward. Now in Mango, what we do is we allow you to create an agent. An agent is really kind of another DLL that's part of the application. It's accessing the same ISO store. In fact, it really is part of the app. There's really a better way of thinking about it, but it is a separate DLL. It actually runs in a separate process. And a lot of that is we kind of go, like, why is that? What's going on there? We go back to our audio example. What was happening there is I had an audio, I started my audio, I exited back to the wallpaper or to some other application. My app didn't run it at all. And the system, though, the Zune service knows, hey, I'm starting to run out of music here. I need to know how to get the next track. Or the user has pressed in the UVC, Universal Volume Control. I probably shouldn't have used that acronym. That's what that little volume control thing in the UVC. The next track, how do I process that? And so the system says, hey, what application was playing this audio? I'm going to fire up its background agent. So the system is calling out or firing up that agent and saying, hey, provide me the next track. And that was the API that I showed earlier. So these agents are really, again, kind of transient services invoked by the system based off of certain system events. And we'll get to more of these. This is really kind of the first instantiation of them. So from the OS's side, this application or this agent again is part of the app. It's treated as a single entity. It's installed together. It's uninstalled together. It's updated together. Also, to kind of complete the end-to-end is from the developer's perspective. I have kind of a nice little solution here. It's really kind of part of the same solution. As Vibor mentioned in an earlier talk, we provide full debugging capabilities for being able to bug not only your foreground app like you do now, but also the background application. Now, one thing that's kind of interesting is, since it is part of the same app, it adheres to all the same capabilities. So there's only a single manifest file. Right? So my manifest file is kind of part of my foreground app here, and my agent also adheres to all the same capabilities. So again, it's all really one application. And again, it's all debugged together. So if I have a project, or excuse me, I have an application that has an agent, I go and debug it, the debugger will attach to both those processes and allow me to debug things. Okay? All right. So what are these agents? What can they do? Actually, they can do quite a lot of stuff. Namely, what they can't do is UI, which kind of makes sense. They're running in the background. We don't want a bunch of random UI popping up all over the place. We provide some nice ways of providing UI, like with alarms, reminders, tiles and toasts they can do. So we have nice affordances already in Windows Phone to inform the user of activity via push or via the application. In this case, via the application through its background agent. You can get location. I'll get into that in a little bit. You can access the network. Of course, read and write ISO store, access structured storage, utilize sockets, most of the APIs outside of UI. Now, there are some sensors that are restricted. We kind of really looked at this and go, okay, we'd like to provide as much capabilities as we can, but let's look at what we're really providing here to the user, going back to that great user experience that we have, to that tenet that we have an application platform where a user never regrets installing an app. And we apply that to the sensors, and we came up with a couple that seemed a little fishy, like the microphone and camera. There are scenarios we could probably think of where a microphone would kind of be handy as a background agent, but it also, there's a privacy concern with both camera and microphone. So at least for Mango, what we said was, you know what, I think we're going to err on the privacy side. We're not going to allow that. Feedback would be great on that, by the way. But that's why we came up with these, in particular, these two sensors not being used. Some of the other sensors are not available as well. And really, it's around maintaining that great user experience. I mentioned audio here. We do provide background audio APIs like I just discussed. So some of the other APIs are disabled. So to kind of make sure that we're calling through the right APIs to kind of achieve the right user scenario. All right, we talked about a lot of great functionality in terms of audio, fast application switching and resuming, background transfers, a bunch of really alarms and reminders. So much I forget about them. There's a lot of stuff here. But there's other stuff that I'd want to do. And this gets to the really juicy, fun stuff. Like, what about data syncing? There's a number of questions in previous sessions about data syncing. What about social location, like your loop Foursquare type scenarios, like the one I had here, where I was auto-checking in? What about tracking, Runkeeper, Nike Plus, these types of scenarios? What about those? So for those, we have what we call generic background agents. And what these are is a couple different types of them. One is called periodic. One is called what I'm calling on idle, or what ISFON called on AC. But there's kind of two different types. An application can utilize one or both of them along with an audio agent. So if you really want to get wild, you can do you can have an app that has both audio, alarms, reminders, both audio agents, a periodic and a non-idle agent if you really want to go to town. And actually there's interesting scenarios for that. If you do have an audio application, clearly you'd use the audio APIs, but you also might want to sync a lot of that content in the background. And so we can imagine some nice applications that might want to utilize all this functionality. You don't have to. I'll get into some of the details of these in a sec. The scheduling of these agents is persisted across reboots, which is pretty nice. So it kind of continues that great experience that you've teed up for the user. The user goes in, uses your application, and that experience continues across the reboots. However, the user still has some control. We do provide a CPL to allow folks to turn off just the background agent, or actually to turn off the periodic agents for your application. And the periodic agents that you'll see in a little bit here, and I'll demo the CPL, are the richest agents that we have, but they're also potentially the most damaging when it comes to health, which is why we provide the CPL, which is also why we provide a max. So Isfa and I talked about this as well. We're doing a huge amount of work in terms of resource management, looking at the power of the system and of the applications and of the model that we have. And with these power models, we're like, okay, there is some maximum where n number of agents will really make a phone fairly crappy. And with our power models that we said was somewhere around 18, as we modeled it through with our power budget, seemed like about the right amount. Again, great. This is a conversation, 72-hour conversation, so feedback on any of these numbers would be great. So definitely email me or come up to me after the talk, and we can talk about these numbers if something feels too high or too low. That's kind of our starting bid right now, actually kind of what's checked into the code now. This seems fairly reasonable. What this would really mean is that you'd have 18 apps all participating in some sort of periodic activity. This is outside of audio, by the way. Audio doesn't count towards this. Neither do the on-idle. And we'll talk, again, a little bit more what that means. You can synchronize your activity of your agent with your foreground app through mutex that we provide. So you can kind of synchronize the conversation there if need be. Most of the chatter between a background agent and a foreground we've seen is really in the audio case. And in the audio case, you actually do have a fairly rich set of APIs through the Zoom service already, right? So the foreground app is saying, hey, next track, that invokes through the Zoom service to your agent. And so we kind of provide a communication through the service in the case where it's the most needed, which is for audio. But if you need to synchronize activity, especially reading and writing activity, to say to ISOstore, we do provide a mutex because these are running in two different processes. We need to provide something in the system to allow you to have consistent data. Now, lastly, is that these agents, periodic agents, run for only 14 days. In the API, developer can say, hey, I'm going to add this agent. Here's the schedule. Here's the number of days it should run. And we cap it at 14. You can say 30. It'll still only run for 14 days. Now, if the user goes back into your application, you can go ahead and renew that. So if the user is using your app all the time, you don't have to worry about this 14 days. Who cares? So why did we do this? We did this to eliminate, basically remove the problem we currently have on some OSs, I mean, Windows included actually, where you just get CRUD being built up in the system, right? And we wanted to avoid that on the phone, right? And so what we did was we capped the time in which these agents can run to about 14 days. Again, feedback on that would be great. It seemed to have resonated so far with the folks we talked to. And really what that would mean, if the user has not gone back into that application within 14 days, they probably really don't care about the background activity happening in that application, right? But this really was our way of mitigating and really eliminating this CRUD buildup that you can see in a system. Okay, so generic types, so dive into the details. Periodic agents, they run every 30 minutes. They run for 15 seconds. Again, these are numbers that I'd love to get feedback on. The scenarios that we're thinking of for this is what I'm calling incremental data sync. Let's say we've sunk a lot of data either in the foreground, and over the course of the day, I want to kind of update my news feed, or I want to update either say Twitter or podcast or something like that. Actually, podcast is not the right example, but some sort of a news feed type of scenario would be a good example of this. Also, social location, where I want to post my location up to my cloud service. Let's say I have a geocaching application. It's keeping track of the geocaches in the cloud as well as my user's location. but I need to know the user's location. So every half hour, it can post the location up to the cloud. The other type of agent we have is the on-idle agents. And these are kind of cool in that these will be invoked under certain conditions, not based on time, but based off of a certain system event or events. And these are launched when you're on some sort of external power and when you're on some sort of non-cell network. So, I mean, you can think of this as nightstand mode is a good way of thinking about it. About to go to bed, I plug my phone in, it's on my wireless from my house, and I go to sleep. Well, my phone doesn't need to go to sleep. It can do stuff on my behalf, so why not run a bunch of stuff? Do maybe a large-scale syncing, right? So pull down all the different podcasts and various other things that have happened during the day. During the night, you can pull down, stock quotes. You can pull down news feeds. I mean, you got a lot of time. Each time they run, you got 10 minutes. You can do a lot over Wi-Fi in 10 minutes. So what you can imagine here is using both these together. So at night, well, it doesn't have to be at night, just every time your phone meets these conditions. But typically, let's say at night, nightstand mode, you use your on-idle agent as part of your application to do a large-scale sync. And then during the day, you have a periodic agent that's updating stuff here and there. And of course, there's not as many updates because it's doing it more often. And maybe you can do even smaller updates. So you can use these kind of both together for some nice data syncing scenarios. So I just want to dive in a little bit on what the code looks like. I'm going to go through what a periodic agent looks like. The on-idle agents look very, very similar. So I have my app. I knew up a periodic task. I give it some metadata. Here I'm saying expire after 7 days. If I put 17 days, it wouldn't make any difference. We're going to expire it after 14. We add that task, and that's fundamentally it. So if you look carefully here, the question would be, what in the bloody heck do I run? I'm just kind of newing up an object and some metadata and saying do something. What's being run? Well, what's being run is specified in the manifest. And we specify this here. You can see the type here. In this case, it's tweetagent.tweetagent. So the namespace and type is what's being run. So you specify the type here, specify the metadata and scheduling in the application. And my app is the foreground app. Now, part of the solution, the last little bit here, is the app agent DLL. Talked about this earlier, where our application has, or the solution has 2 projects, the last one being an app agent. In this case, it's tweet agent, inherits from scheduled task agent, and is implementing the onInvoke method. And when it's done doing whatever it needs to do, presumably something about tweeting, it calls notify complete. There are a couple other APIs as well for the system to be able to interrupt and do cancel agents, as well as for agents to issue an error. I just kind of go for the happy path here and simplified path, where it's like you implement onInvoke, say notify complete when you're done. So fairly simple set of APIs, really. So what I wanted to do is get back to the very last box I said of multitasking. We had talked about 3 main facets. There was services, there was agents, and then there's a big green box, resource management. I want to talk about resource management in the context of that phone harmony. So let's talk about that with regard to UX, maintaining great user experience, and maintaining great health. So what I have here is an actual photograph of a Windows Phone user. They're a little jaundiced, but they're very, very happy about their phone. We want to keep it that way. Big smile. So we have that delightful responsive UX. He's not regretting he installed an app. There's a big smile on his face. And it has an integrated feel. So how do we maintain that now that I've just talked 40 minutes or so about all bejesus of features I've just added to the OS, including third-party app execution? Well, first off, we go back to balancing foreground and background. And we do that by looking at CPU and managing and altering the CPU quantum, or the process quantums in the applications that are running in the foreground as well as in the background. Did a bunch of work really over the past couple of years looking at how do we tune and make sure that the applications you guys have written in terms of, let's say, video applications or scrolling applications, that frame rate maintains, although the neighbor next to you has an application that's using a bunch of background activity. Sort of picking on each other here. But really what you want to do is have that your apps continue to run well on Mango, although there's background activity. And we did a bunch of work to saying, okay, let's tweak some of the CPU quantums, tweak some of this between background and foreground to maintain great user experience, as well as giving enough CPU for the background agents to do useful tasks. Another thing that we do, I mentioned this before, is monitor the CPU usage. If someone's getting a little out of hand, we kill them. The other thing we look at is working set, kind of an important aspect of kind of this foreground of the experience is being able to kind of manage the memory. And one way of kind of looking at this is if we can maximize the number of dormant apps, that'd be great, because I can have a bunch of my games running, and I can switch between them and do my phone testing. So that'd be great. But to do that, we really need to look at, well, what's going to utilize the memory? Well, the foreground app does, and we kind of have some of those facilities already in Windows Phone 7. But for the new functionality that we've added in Mango, we said, okay, let's look at these background agents. Well, first off, let's trim out all the stuff they don't need. And that was really us, looking at the platform going, okay, let's get rid of all the UI junk. Let's trim down the working set that Silverlight is using. Get that as small as possible. And say, okay, if I need to build an app on top of that, how much would it actually need to use? And so these are working numbers right now. They may change a little bit. There's comments on them. Definitely let me know. But this is kind of where we're landing approximately. Is about 5 megs for periodic agents. Seems to be enough to be able to do great, useful stuff in the background. That social location, some data syncing, utilize of ISO store network, without going crazy. So we basically cap that working set. You'll get an out-of-memory exception at 5 megs. And again, we'll tune this a little bit, but it's probably roughly around there. And the experiments we've done, actually, that seems pretty good. For audio, you probably need a little more memory. We build our own little audio apps, streaming apps, as well as URL-based apps. You're doing a little bit more with memory. So we're looking at possibly, probably will need a little bit more larger working set for the audio scenarios. The other thing we do with memory is really tune that new service that we added, the background transfer service. Obviously, it could utilize a whole bejesus of memory if we allowed it to. We're not going to allow it to. Our health team is pretty hardcore. And so we really looked at, okay, what is the minimum amount of memory? How do they use memory? How do they reuse buffers? How do we not duplicate code? And so forth. And so kind of limiting its memory usage through what we can tune, as well as limits back out to the developer. For instance, being able to queue up only a certain number of requests. Right now, actually I don't have it on the slide, but right now the working number is 5 outstanding requests, uploads or downloads. Again, getting feedback on that number would be great. But the reason we have that number, and it's not a super high number, is really to help with the memory usage, as well as actually the network, being network conscious. So those are kind of areas where we're looking, that we do in terms of managing memory. Lastly, a set of items. One of the things we do for periodic agents is if you have the phone turned on, we'll run them in serial. So they're not sucking up a huge amount of CPU or memory or other resources on the system. Again, we allocate a certain amount of CPU for them. So if you have a great game, I'll have my great game. I'm playing, what's the game I'm on now? Harvest. I'm playing a lot of Harvest right now. Testing my phone with Harvest. And I want the background activity not to disturb that. So we'll run them in serial. Now with all these things, we do maintain app isolation. We don't have code running on install. And we've enhanced our ingestion rules to basically create additional rules around the functionality that you see here. We enforce as much as we can in the platform, but where needed, we enhance the ingestion and certification rules so applications adhere to what we're talking about. So that's with UX. With health, we have same person here dreaming. That's not a nightmare. He's dreaming about that he has fabulous battery. And that's what we want to maintain in Mango. Great battery, network conscious, having a great healthy phone. So how do we do that? Well, first off, of course, is the system services I talked about. Spending all that time pounding on the new services on the OS, making that platform that you're all using, that you're building your houses, you're building your applications on, to be as good as possible. And that's really us, doing our jobs, hopefully doing a great job at them. The other one is being efficient around network. So network is really expensive from a battery standpoint. Now, when we look at it, if we can align a lot of this activity, so when we bring up the radio, we do a bunch of activity together, and then we can bring down the radio. So we do a lot of that, and looking at that with periodic agents, saying, okay, well, we have this task scheduler that kicks up to do, that fires up the radio, does the very syncing of data on the phone now. Well, why not align our periodic agents to that? That'd be good. So we look at that, we do that, and kind of run them as close together and in parallel as we can, and we'll do that in parallel when the screen is turned off, which actually, if your phone is turned off most of the time, so they're running in parallel most of the time, which is great. Then with the on-idle agents, of course, they don't run at all on the cell network. They run on some non-cell. That could be Wi-Fi, it could be desktop pass-through, either one. So with these periodic agents, I talk a lot about them because they are the most generic. You can do a lot with them. They're also the most dangerous, which is why we spent the most time really on how in the world do we kind of help maintain the great phone harmony with such a powerful entity. We do have a CPL, and actually that's the one demo I'm going to do here. See if my phone is still behaving itself. In the keynote, Joe mentioned, I'm not sure if people caught it, briefly around user control when it comes to agents. And so what we allow you to do, and hopefully users shouldn't need to see this because we've done a bunch of great tuning of the system, but if you need to, you can go into applications. So I went into settings, I went to applications, and there's a new thing called background services. And what it's listing here on the very first screen are all applications that have scheduled periodic tasks. So I've gone into every one of these apps, I've scheduled an agent, basically using the exact code, almost exactly the same code that I had in my presentation, and it shows up here. Now you notice that the first two are turned on, the second one's turned off. And so what I've done here is what a user can do is say, hey, either I've heard that this application does a bunch of nasty stuff in the background, or seems to be doing stuff and hitting the network and so forth. I want to be able to turn it off. We give people control over balancing their battery versus functionality. And I can just go ahead and turn it off. Now also what the user can do is say, hey, I want to turn it off right now. Maybe I'm in an area where it's very, very expensive in terms of cell or Wi-Fi or so forth, and I want to be able to allow the application to turn it back on, and I can go ahead and check the box here. If the user doesn't check that box, as an application developer, too bad, so sad. Your periodic agent will not run, no matter what you do. Right? You can put in the UI saying, hey, user, you might want to turn us back on. But they'll need to check that box. And this really goes into that user control, being around, or especially around battery, being an extremely important, sensitive resource. Now, again, we've done a bunch of work. We've spent a bunch of time over the past hour talking about resource management. We feel that we've done a tremendous amount in terms of helping the user or helping the system be extremely efficient when it comes to CPU, memory, network, and battery. The reason we have the CPL here is with battery, it's hard to know kind of the fullness of the user's intent. Is the intent for me that I want 18 background agents doing a bunch of cool stuff? Maybe. That'd be great. Maybe that's my scenario. Maybe it isn't. Maybe I want to utilize heavy video. Or really probably for me, it's probably more along the lines of the Xbox Live games that I'm playing. That's where I want to spend my battery. I don't want to spend my battery on these. And so that's why we provide the CPL. The kind of the hope here is for the vast majority of users, they never have to worry about it. Right? They never even know about it. They never go here. We'll see. That's kind of the hope. I think for more power users, developers, you probably will utilize this a bit more in debugging apps and looking through applications. But hopefully for the general populace, people aren't utilizing this. A couple other quick notes. One of them, this text at the bottom here is actually provided by the application. So when you add that description that I had in my API, actually is this description here. So you can provide to the user, hey, my application's doing cool stuff, don't turn me off. Or some sort of text to say, hey, here's what this agent is doing. The other thing to note here is these are the periodic agents. If I press more, this is a periodic and idle agents. Now we don't, these set of dialogues, and really for the entire phone, we try to keep the UI as simple as possible. If you look at what we did from Windows Mobile to Windows Phone 7, we took out a ton of UI to really make things and simplify the UI and have that a delightful, responsive, and smooth experience. So carrying that idea forward, here we try to simplify and the UI as much as possible. With this dialog, it lists the periodic and idle as an awareness to the user. We don't worry as much about the idle agents because they're not using battery. They have to be powered, remember, and they are going to be off-cell. So these the user shouldn't have to worry about nearly as much, but there's at least awareness of what's running in the background. Maybe in the future we add some more control. We can get some feedback around that. But for now, we just kind of wanted to start at least with awareness. All right. Let's kind of go back to the presentation. So, just in summary, the multitasking features of Mango are a natural extension of what we have now with 7. You looks like a lot of people have been writing applications for 7, which is great. It's a natural extension of what you've been currently working on. For those that haven't, you can pick up the tools today. I know we're going to update them in May. That's okay. You can start today learning about the application model, Silverlight, XNA, so forth. What we have here in Mango is a nice extension of that. Talked about fast application switching, my favorite feature. I definitely love this. New set of system services, the background notification service, allowing you to do alarms and reminders, and the transfer service, allowing you to do background uploads and downloads. And for that matter, you don't have to necessarily use it in the background. It's a really, really nice API just in the foreground. But, of course, if someone backs out of your app, those transfers continue to happen. So really, really nice service. Background audio, we have 3 different ways of doing background audio: HTML5, file-based or URL-based, and streaming. So really, really nice, very rich ways of providing background audio. And last but not least, a set of generic agents to allow you to periodically execute code or run code when the phone is quote-unquote idle in that nightstand mode. And this takes us back to the very beginning, which we had Windows Phone Harmony. And I would assert that even with all this great functionality, we still maintain the great UX and the great health that we had in Windows Phone 7. Thank you. So just one quick thing before Q&A. I did want to highlight part 2. So the masterful Mr. Peter Torr will be doing the deep dive into code. Again, he's limited to less than 5 slides. We'll see if he does that. But actually, seriously, he has pretty much the entire coding presentation tomorrow at 10:30, so I very much encourage you to go there. He's going to dive into a lot more of the lower-level details. So actually, I'll keep this on the screen to kind of burn it in your retinas. All right, Q&A, yes?
Hi, I'm Victor Larsson from Avanade, Sweden.
Hi.
I have 2 questions regarding reminders.
Yes.
First of all, I saw during the code you had content. So can I put anything in a reminder? Can I put an image in there?
You can't put, so the question was, what can I put in the reminders? So the reminders, what I had was text, and that's what you can put in is text. Mm-hmm. They follow the same pattern as what we have with the reminders currently on the phone. So it's kind of pretty much an API sitting on top of the reminder facilities you currently have in the calendar.
Can I do a custom interval for the reminder?
I believe so, but I can double check on that.
Okay, thanks.
Yeah.
My name is Jugs, and I think now Windows Phone 7 is becoming a true mobile OS platform, so thank you so much for this. But I think I'm still confused by a lot of the multitasking things that were pitched. So for example, if I'm a background service and I'm doing Exchange Sync solution, I ping, I do a live ping, and then the network stack takes my request. But then I only run every 30 minutes or so, and then when the data comes back, I'm not even there.
So the question is, how do you do something like data syncing?
Yeah, like most of my scenarios, want me to be there when the network comes back and tells me, here's data for you. But you're running me every 30 minutes and you're giving me these 15 seconds, which the ping solution goes to the server. It's parked there until the data actually comes, or a new email or SMS or an IM message or a Skype phone call comes before.
Okay. So there's a question around that the frequency may not be as frequent and the duration is definitely too short. Is that for some of your scenarios?
I'm trying to find a good way or an example to share this, but I'm wondering whether you allow from external notifications to launch applications.
Okay. So the question is, kind of externally, can we, let's say from push or some other external mechanism, be able to launch third-party code?
I think that would solve a lot of the scenarios that I'm
thinking
about.
The simple answer is no. But I'd love to hear the various scenarios for this, because this is something that's kind of in our queue of requests in terms of what we would want to enable. But for currently in Mango, we don't allow that.
Yeah, I mean, your code does that, so.
That's right.
Okay, thank you. I got it.
Yeah.
Excuse me.
So I mean, well, our code doesn't do it. I mean, it's for instance, the IMAP and POP syncing is very, very similar to the facilities that you get with periodic tasks now. So Exchange, you're right, is a little more interesting.
So.
That's right. I'm sorry. Go ahead.
A bit on the background transfer service. It's a bit the same question, but more specific. So would you say that this service is suitable to do DB sync with something like OData? Or would you have to resort to the sort of custom agents?
So the question is the background transfer service suitable for OData? It should be. I mean, we can look into the exact scenario and what you're doing with that, but it should facilitate OData transfers.
So presumably when the response comes back, it goes into a DB instead of going into plain old isolated storage?
Oh, I see what you're saying. Yeah, so, well, actually, the answer may be no for what you're asking. So what will happen is that you'll say, go and get this URL and plop it into this URL. So source, let's say in the cloud, and destination, which would be on ISOstore. Yeah. So in terms of being able to have that plop into, let's say, structured storage, it doesn't facilitate that directly.
Okay, cool, thanks.
But that's a great scenario. Yeah, in the front. Sorry.
All right.
Yeah.
You said that we get 15 seconds to run our application on the periodic.
That's right.
Okay. So if we're going to call out to, say, a web service that's really slow, can we say, we're not running right now, just wait until this web service gets back? And that, in other words, if the web service takes more than 15 seconds, does that just get dropped? Or?
Right. So the question is, for a periodic task, what happens if, let's say I'm talking to a web service and it takes longer than 15 seconds? So there's a couple things that could happen. One, you can cancel your task if you want to. If you want to be a great citizen on the Windows Phone and say, hey, I'm not going to be able to complete anything. Things are taking longer than it should. I'm hitting error conditions. There's an API I didn't show here. Peter will actually go through that tomorrow. But there's an API you can call saying, I'm done. Cancel me out.
Thank you.
The other question was, I guess I was wondering of the duration. Is that a major concern? Because what would happen in that scenario is you'd cancel out, get scheduled again in another half hour.
No, that's fine. I just
Okay.
wanted to.
Yeah, so yeah, you're able to do that. Sir, do we have somebody after me? Oh, we can take a couple more questions. Oh, that's fine. Okay. So we're out of time for the facilities, so we can just take questions up front. So we'll turn off all the mics and everything else. So thanks a lot, folks.